Hello, my Math 40s. This is week 10, lecture 2. Let me go ahead and write some of this in. And essentially, I'm going to be covering the remainder of chapter 4. I already put up on the warm-up page which problems we'd be going over today. So I plan on getting through 4.1, 4.2, graphing those reciprocals, and then also going over 4.3, which is graphing tangent functions. So finishing chapter 4. Okay, so your warm-up, hopefully you've already watched the last video, at least skimmed it, if you were having trouble graphing trig functions. But I go over the process of how to do that for the sine and cosine functions. Okay, so this was the classroom example I gave you for a warm-up. If you remember, just kind of going back over the steps, the first thing that we're going to do is find the amplitude of our graph, find our b value, which is our horizontal stretch and shrink factor. And then from there, we're going to find our period. Remember, the period is going to be 2 pi over b for sine and cosine functions. We're also going to find our c value, which is vertical shift, and we're going to find our, c value is vertical stretch or shrink, and d value is horizontal shift. So let me write these out real quick, just in case you weren't here last time. Okay, so remember the form that you're matching to. Let's do this in another color. Our form, we're matching to y equals, in this case, c plus a times cosine of the quantity b times x minus d. This whole b times x minus d is in the argument of cosine. Okay, and those b and d values actually affect your x values. From the parent graph, and a and c affect affect y values. So I already covered that in the last video, so if there's still some confusion, go back and check that first, and then you have questions, you can ask me. So here, let's start with the parts that we see the most. We see a 1/2 inside of the argument of cosine. So b is actually going to be equal to 1/2. What else do we see? Like, not really much, right? So in terms of what's in front of the cosine, in order to not multiply this by a 0 or multiply it by some other number, like if you saw another number, it'd be here. If you saw a 0, none of this would be here. So if you don't see a number in front of the cosine, that means you're multiplying by a 1. Okay. And then for your c value and d value, they're still going to be 0. We'll see the difference when we get to our other problems if you don't see it quite yet. And then the period is actually going to be 2 pi divided by b. So be careful here. You have 2 pi divided by 1/2. So your period is actually going to be 2 pi times 2 over 1, 4 pi. Okay, so these items we'll need before we continue. The second part that we needed to do was find how we shift. And by doing that, we place b times x minus d between 0 and 2 pi, and we solve the inequality for x. That will give us the endpoints for our x value shifts. So in this case, b times x minus d is right here because that's all the argument for cosine. So 1/2 x is going to go between 0 and 2 pi. And then we're going to solve out for x. So kind of think, if I have a 1/2 in here, how do I get rid of that connected to the x? I'd multiply it by 2. So I'm going to multiply everywhere by 2. And then I get 0, x in the middle, and I get a 4 pi. So those are going to be my end values for x. Okay. For part 3, we're finding the other 3. Find 3 middle x values. I'd recommend just using averages for this part. So essentially, we have x values. The n values will go here. We need to find this one, second one, third one. Okay, so if you missed this part last time, essentially by doing the average, we're taking the n values and adding them and then dividing by 2. So 2 pi will be in the middle. 0 and 2 pi average is pi. And 2 pi and 4 pi average is 3 pi. This one's actually kind of nicely countable, but not all of them are. So definitely get familiar with averages for this. So we found our middle x values here. Let me go ahead and save this picture so that I can clear out the side here. Okay, part 4 is to find y values based on the x values we have here. So let me add a 4 in here. And in case you haven't checked out the video yet, do check it out, the last one, because it covers this in some detail. But essentially, when you're checking, if you're not sure about any shortcuts or anything at this point, actually go back and plug in values. So y equals, I have cosine of 1/2 times my x value. So this is when x equals 0. So that's cosine of 0. And we know that cosine of 0 is 1. I'll do one more for good measure, but I'm going to plug in the rest after to make it a little bit quicker. So we have cosine 1/2 times pi. That's going to be cosine of pi over 2, which is 0. Okay, I'll do one more for good measure. So if x is 2 pi, y equals cosine of 1/2 times 2 pi, which is cosine of pi, which turns out to be -1. Okay, so then from x being equal to 3 pi, you're going to get 0, and x being equal to 4 pi, you get 1 for y. So that takes us to our 5th step, which is the graphing portion. What I'm going to do, I'm going to go ahead and I already saved this. I'm going to clear out the side screen here so that I can put the points we have. And then I'm going to clear out this part of the screen so I can actually draw those points in for part 5. So erase. Okay. So for part 5, that is not a 5. Okay, we're going to graph. We have the points x, y. So from our first point, we have 0, 1. We have pi, 0, 2 pi, -1, 3 pi, 0, and 4 pi, 1. Okay, so that's what we're going to be graphing. Sorry, bear with me. I have not figured out a way to clear out the entire screen while just saving some parts. So I have to do this every time. Thanks for bearing with me. As a matter of fact, I'm not going to lie, this process has not been easy. I haven't taught an online class ever. So I'm trying to get 4 classes online right now in a very short amount of time with all this other stuff happening has also been very stressful for me. Okay, so here we go. We're going to be ready to draw these. So we have 0 up to 4 pi. So kind of a good way, if you are graphing and you don't have graph paper, you can just make like a horizontal line and then break up your section into 5 pieces. So 0 would be here for x. And then we can just put, we can just put 4 pi right here. Okay, so then in the middle would be 2 pi. And then in the middle of 0 and 2 pi would be pi. And in the middle of 2 pi and 4 pi would be 3 pi. Okay. So let's go ahead and graph this. We've broken up our horizontal into 5 different x values, which leads us to 4 parts here. And then for the y values, look for your max and your min. My max is 1 and my min is -1. Okay, so 0, 1 is here, pi, 0, 2 pi, -1, 3 pi, 0, and 4 pi, 1. Now, I don't think that this is going to go very smoothly in terms of graphing it, but I'll do my best. It should look like a very smooth curve. Okay, let's give it a shot. Okay, and this is over 1 period. Okay, so that completes this particular problem. Before I ask you guys about any questions, I'm going to add the extra examples. So for one, So extra example. Let's graph y equals 3 cosine 1/2 x over this same plot. Essentially, you would follow the same process. The main thing that I want you to note is that the y values you got from cosine of 1/2 x are going to be the same y values you had right here. Because remember, this function here was cosine of 1/2 x. So what we're going to do when we're plotting, we're just going to multiply these y values by 3. Okay, so if you need to, do the whole long process out, but a shortcut for you, x, y. The x values will still be 0, pi, 2 pi, 3 pi, and 4 pi. But now, kind of think if I plug in 0, 3 times cosine of 0 is 3. If I plug in pi, cosine of pi over 2 is 0 times 3, 0. Plug in 2 pi here. That gives me cosine of pi, which is -1, and then I multiply by a 3. So that amplitude essentially amplifies your graph, right? So I kind of wish I had done a little bit better here in terms of scaling. Let me go ahead and save this. And then what I'll do, I'll just draw it again, this part. So I'm gonna put, oops. Okay. And then let's go ahead and graph our old function. Oops, it was here. Oh, actually, let me redo because I forgot. I just changed my whole system here. So let's redraw these points. We have 0, 1, pi 0, pi, sorry, 2 pi, -1, 3 pi 0, and 4 pi 1. So this, getting a little better. Okay, I spoke too soon. This is actually really hard to do on a graphing tablet. I don't know if anybody has one. If you have any tips, that would be useful. Okay, I graphed this in Desmos last time, but just for time purposes, I don't want to do that right now. I can help you out with that part at the end during the question and answer if you have any concerns about it. All right, let's graph these points for our second graph that was added. We have 0, 3, and pi 0, 2 pi, -3, 3 pi 0, and 4 pi 3. Okay, let's give this a shot. Okay, I cannot make this correction enough. Okay, I'm definitely gonna have to do these in Desmos next time. Like just have backups. Oh, come on, man. Okay, so I kind of hate to say this, but it actually is sort of a useful way of me remembering what these graphs look like. It sort of looks like a uterus for a cosine graph. So just kind of think this should be a bit more curved out. But I'll show you guys over a Q&A if you need more help with that. So we have y equals 3 cosine of 1/2 x here. We have y equals cosine of 1/2 x. So do you guys see that from cosine of 1/2 x to 3 times cosine 1/2 x, we actually amplified our original graph, this one, by 3 units in the y direction. Okay. All right, and then just one more for good measure. You can try this later. Call it extra example. Graph y equals cosine x on the same plot. Okay, so if you follow that process that we've done before, what you're gonna find out is that the period is actually gonna be 2 pi for this particular graph. So your x and y values, 0 to 2 pi. We talked about this in the last video, how you get the middle values. Okay, and then y values you'd find by plugging in. This will be 1, 0, -1, 0, and 1. So what your original, this is called the parent graph, because it's unshifted. We're gonna have 0, 1. We're gonna have pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. So this is y equals cosine x, parent graph. So note what happens here from the cosine x graph to the cosine 1/2 x graph. We've actually taken our parent graph and stretched it by a factor of 2. Okay, stretched by a factor of 2. Now, when we took this particular graph and then multiplied it by 3, we vertically stretched by a factor of 3. So definitely practice with it. I would say for now, with the tight schedule we have, just practice the method, making sure that you're able to graph. So let me save this, and then I'm going to pause the recording and ask you guys if you have any questions. Hold on. Okay, so now that I've gone through that, I've cleared out my screen, and I have put over here what we graphed for y equals cosine 1/2 x. So what I want to cover next, before we continue too far, is how to graph the reciprocal function. The reciprocal function would be y equals secant 1/2 x. Okay. This would actually be included in section 4.4, but I always like to teach the sine graphs and cosine graphs with the cosecant and secant graphs, because if you can graph the cosine and sine graphs, you can graph the reciprocals easily without needing to do any charts. Okay, we'll cover that again, but let me go ahead and change the color here on this. I realize we need a different color. Let's do something really dramatic. Whatever, it's good enough. Y equals secant 1/2 x. Okay, so to start, graph y equals cosine 1/2 x. using the process we've already discussed. So I discussed that process in both the last example and the last video. Let's go ahead and graph. Crapola, come on. We had 4 pi out here. And then in the middle is 2 pi. In the middle of that is pi and 3 pi in the middle. Okay. So we graphed, oops, 1 second, one more thing. Put my y values here. Okay, I think that's going to be a little bit off. Okay, so we have 0, 1. We have pi 0, 2 pi negative 1, 3 pi 0, and 4 pi 1 from the y equals cosine 1/2 x graph. Come on, come on, come on. Oh, couldn't do that part. Nope, couldn't do that either. I'm just gonna erase it. Kind of getting the hang of this. Okay. So now when we are graphing the secant graph, all right, start by graphing the cosine graph, check. And then let's make a table. It'll make it a little bit easier to understand. My x values. And then I'm going to have the y values if I had cosine 1/2 x. And I'm going to have the y values if I have secant 1/2 x. Okay, so trying to find the x values will be the same for both of those graphs. Okay, we already plugged in what we should have here: 1, 0, -1, 0, 1. Okay, here's your hint, your tip. Save some time. Anywhere there would have been a 0, like a middle value for your cosine graph, you're going to have an asymptote, undefined, for your secant graph. Okay, and then anywhere you have like whatever value this is, if it's a 1, you're going to have the same value for secant 1. -1, same value. 1, same value. Okay, I'll look at that in further detail in a second, but here's how your graph looks. Okay, so you see this? All right, I have 0, 1. I have an undefined at pi, that's a vertical asymptote. At x equals pi. So I'm going to have a vertical dotted line right here. Why is that going sideways? I miss paper in a doc can. Okay. All right, I have 2 pi -1. I have a vertical asymptote at 3 pi. And then I have 4 pi 1. Watch the end of my last video. I covered this in depth, but essentially if you have a max, you see how this would be a max for the cosine graph we have, max y value? It now becomes a min for your cosecant graph. And this side here just approaches your asymptote. Okay, so same thing over here at 4 pi, we have a max for the cosine graph. So it'd be a min for the secant graph. At the bottom here, we have a min for the cosine graph. That would be a max for the secant graph. So hopefully you're seeing the pattern of how you would draw this, and then you don't need to worry about a whole separate process for this, okay? So then what would happen here if you were just drawing the cosecant graph completely by itself? You would just erase this part, and that's your cosecant graph. Okay. So this graph here that we just drew is y equals secant 1/2 x. Okay, now one last thing before I move on, check y values. So if I have y equals secant 1/2 x and I let x equal 0, remember, where is it, eraser. Secant 1/2 x is the same thing as 1 divided by cosine of 1/2 x. So y would be equal to secant of 1/2 times 0, which is secant of 0, which is 1 divided by cosine of 0. Cosine of 0 is just 1. Okay. So y equals 1, which checks out. Let me save that picture. Let's try one more to see what happens with the asymptotes. If I have x equals pi, when I plug in y equals secant of 1/2 pi, that is secant of pi over 2, which is 1 divided by cosine of pi over 2. Cosine of pi over 2 is 0. Okay, which is undefined. So that's the undefined we get here. So again, still go back and plug in stuff. Remember your reciprocal functions, and you should be okay with this. So we have covered 4.1 and 4.4 at this point. The next problem I'm going to do is 4.2, classroom example 1. So let me go ahead and save this and then pause recording if you have questions. All right, guys, now we are going to move on to section 4.2. We've already covered sections 4.1 and 4.4. So for 4.2, the first problem we're going to start with is classroom example 1. Remember, you have this stuff in your notes for now. I can go ahead and fill out this chart just because it's here. Okay, so if you have a graph of a function, essentially your parent function would have been y equals f of x, but now your function has been shifted by this d value. That d value actually shifts you horizontally compared to your original f of x function. The translation is d units to the right if d is greater than 0. and absolute value d units to the left if d is less than 0. So a quick example, if d is equal to pi over 2, that means I have shifted pi over 2 units to the right. If d comes out to be negative pi over 2, that means I have shifted an absolute value of d, which is still pi over 2 units, but I've shifted this time to the left. Okay. All right, let me go ahead and clear that out and then move this down so we'll have a little more room, hopefully. Yes. Okay. All right, so the process is going to be the same. All right, we're going to start with part 1, which is to identify your amplitude, your horizontal stretch factor, and your period. You're going to find your C value, which is vertical shift, and you're going to find your D value, which is horizontal or phase shift. So basically, look at this part here. For A, that's the part that's in front of sine. If you see nothing, it's a 1. For B, that's the part that's in front of X. That's going to be a 1. For C, there's nothing added outside of the argument of sine, so it's 0. And then for D, we're trying to match to this form. Let's do over here so it'll be seeable. C plus A sine of B times X minus D. And we have Y equals sine of X plus 3 pi over 4. Okay, so that's why C is 0, A is 1, B is 1. D here, change this to sine of X minus negative 3 pi over 4. Okay, and then this becomes your D value. So D should actually be negative 3 pi over 4, or 3 pi over 4 units to the left. Okay. So our parent graph, sine X, will be shifted by 3 pi over 4 units to the left. Now the period, remember, that's still 2 pi over B, so in this case, it'll just be 2 pi. Okay, save that. Let me go ahead and erase this part here. Okay, and then we're going to move to part 2. Which is to find your n values, your x values that are shifted. So again, between 0 and 2 pi, we're going to put b times x minus d. Okay. B times x minus d is whatever's in the argument of sine. So we're going to put x plus 3 pi over 4 between 0 and 2 pi. Okay, now we need to isolate x, so we're going to subtract 3 pi over 4 everywhere, on the ends and in the middle. Okay, so it's going to be pretty nice on the 0 side. It's just going to come out to negative 3 pi over 4, and x in the middle. For this part, though, remember you have a 2 pi Actually, let me just put it right here. We have 2 pi minus 3 pi over 4. Remember, common denominator would change 2 pi into 8 pi over 4. Okay, and then on the right side, we get 5 pi over 4. Okay, so our n values will be negative 3 pi over 4 and 5 pi over 4. So let me do it over here, x. So in step 3, we're going to be finding these middle x values using averages. I'm going to go ahead and clear this side out. Let me select this. It's a new trick I learned yesterday that's been working wonderfully. Okay, maybe not. I jinxed myself. Let me undo that. Select this, move it here. And then let me erase. Okay, so sorry, it's taking some time here. All right, so essentially we need to find averages again for this part. Let me do this in a slightly different color right here, just for the first one, so you can see how the average part's working. So the average, remember you take your n values and add them first, and then divide by 2. So that's going to be, 2 pi over 4 divided by 2, which is 2 pi over 4 times, actually, let me do this part first, divide by 2 over 1. That's 2 pi over 4 times 1 over 2. So 2 pi over 8, which is pi over 4. Okay. And you're going to repeat the averages similarly with the other 2 values, 2 x values you're looking for. So if I want to find this particular value, I'm taking this x value and this x value and averaging them. Okay. So I'll go ahead and plug these in. It's going to be negative pi over 4, and then here will be 3 pi over 4. And then that covers step 3. So let's go ahead and erase. And then we can go ahead and, actually I'm gonna wait on putting the graph together, sorry. All right, now for part 4, we need to find our y values. Remember that's from plugging in. So like example, when x is equal to negative 3 pi over 4, y equals sine of 3 pi over 4 negative plus 3 pi over 4, which actually equals sine of 0, which would be on our parent graph. And that would give us a value of 1. Let's try, oops, sorry, that would give us a value of 0, my bad. let me restate just to make sure we're clear. Okay, so sine of 0 is on the parent graph or parent function for sine, but sine of 0 should be 0. Okay. And then let's try another one. Negative pi over 4. Y equals sine of negative pi over 4 plus 3 pi over 4. That's sine of 2 pi over 4, which is sine of pi over 2. Sine of pi over 2 is 1. So 0 would be here and 1 would be here. Once you get these values, you can kind of guess what the other values should be. This should be 0, -1, and 0. You can always check with the calculator if you need to, and let me know if you need help with that. Okay, I've saved that. Let me go ahead and erase this bottom part here. I need more colors here. Okay. Anyway, so part 5. Graph the points. I hate this thing sometimes. I really do. Oh. Okay, 5 pi over 4, 0. Now, I actually hate the way that this is lined up. I had to do a lot of revamping and measuring to try to make it work. So if you were to write this on paper, you could actually make your own graph. And of course, if you need help in MML with how to graph, let me know, because there's some common issues, like if you're trying to put in a pi, you need to write in pi. And yeah, so just let me know if you have any issues with that. Okay, so if you have trouble with spacing here, just go ahead and make your line for x values, and then put your n values, -3 pi over 4 up to 5 pi over 4. Middle, middle, middle. So this would be negative pi over 4. This would be pi over 4. And this would be 3 pi over 4. And then your max is going to be 1. And your min will be -1. Okay, so the reason why I did that, if you're trying to find out where the y-axis is, it would be right between negative pi over 4 and pi over 4, but it makes your spacing weird up here. You can try it and just let me know if you have any troubles with it. You won't have to do it quite this ugly. Okay, so here we go. We're going to graph -3 pi over 4, 0, negative pi over 4, 1, pi over 4, 0, 3 pi over 4, -1, and 5 pi over 4, 0. Okay, so that's the graph of y equals sine of x plus 3 pi over 4. All right, so our original parent graph, this one would be shifted this way to the right by 3 pi over 4 units. Do I want to draw it on the same one? No, I think I'll just do it on Desmos later. And if you have questions, you can ask me about it. Okay, let me save that and clear. And then I will ask if there's any questions. All right, everybody. I think I am actually going to shorten this video. I'm not sure if I'm going to be able to get into the tangent and cotangent graph in this particular video because it's already kind of long. I'll wait and make those separately. Do look out for an email from me soon about your exam as well. I'm not really happy with that process yet, so I will keep you posted on if it's supposed to happen via Sunday or not, but I don't think it's going to at this point. Okay, so now what do we do when we have a combination? Essentially, we have a few problems with classroom example 5. One, let's just start with the form that we're trying to match to. And we're actually only going to do this over one period. For your graphing for exams, I'm not going to ask you for more than one period. Okay, so your form C plus A times sine of B times X minus D. So for this one, right under it, we can match with y equals 4 minus 2 sine. We have 3x minus pi. This is not the form b times x minus d. Notice that there's a factor right next to b here, but there's not a factor right next to b here. Okay, you don't see parentheses between the x and the d value. So we have to do some rearrangement. For 1, 4, I'm going to put a plus sign here to match form, and then give the negative to the 2 for the a part. And then we have sine. I'm going to factor out b, factor out a 3, and then I have left over x minus pi over 3. If you're trying to figure out how I got that stuff, okay, so if you factor out a number, so 3x, I'm factoring out a 3, I would be dividing. If I have pi, and I'm factoring out a 3, I'm dividing it, and there's the negative between, so just keep it. Okay. So we can go ahead and start with step 1 from what we've done with the formatting. We have we have our amplitude as the absolute value of -2, which is 2. We have b as 3, which means our period is 2 pi over b, 2 pi over 3, okay? And then c would be 4 in this case, and d is a positive pi over 3. We have the negative already matching form. Okay, so what do these things mean? The amplitude means that we are stretching our graph vertically by 2 units. And then for our horizontal stretch or shrink, we are shrinking by a factor of 3. Horizontally shrinking by factor of 3. And then we are vertically moving graph up by 4 units, and horizontally moving graph right by pi over 3 units. Okay, the gist of things. All right, I'm gonna go ahead and clear some of these items. And I'm going to move these. Okay, so then step 2 is next. We need to find the in values for x by putting b times x minus d between 0 and 2 pi. Okay, and then in this case, b times x minus d is right here inside the argument of sine. Okay, all right, now we want to isolate x. So this will take some algebraic steps. You're going to add pi to both sides. And then you are going to divide by 3. So once we get to step 3, where we have to find the other x values, the middle 3 x values, we know that pi over 3 and pi will be the end values. All right, step 3 is finding those middle x values. So we're going to do that using averages again. I'm just going to fill it in for now, though. And then we'll get y values out for part 4. And remember, you plug in your y values, so you plug in your x values into your function. And whatever y pops out, that's what you're going to put in here. So let's just practice with like one of these. When x is equal to pi over 3, y equals 4 minus 2 sine of 3 times pi over 3 minus pi. So that's 4 minus 2 sine of pi minus pi, which equals 4 minus 2 sine of 0. That's 4 minus 2. Sine of 0 is 0. So we get 4 out. Repeat the process. You're going to get a 2, 4, 6, and 4. Just to make things simpler for you, for your exams, I'm going to use some pretty basic examples for this, nothing too extreme, just because I want to make sure you guys are getting the basic process. I know that this has been quite an adjustment. Okay, so let's save that, and then we're going to be ready to graph next. I'm just going to clear that. That's okay, I'll just leave that here. Okay, so here we go. We're going to go ahead and plot this out. Let's put pi over 3 right here. 2 pi over 3. And then 3 pi over 3, which is pi. And then in the middle, we're going to have 2, 4, and 6. Since 2 will be our min value for y, 6 will be our max, and 4 will be our middle. So pi over 3, 4, pi over 2, 2, 2 pi over 3, 4, 5 pi over 6, 6, and pi 4. Okay, so lots of things going on right here. Let's look at our form again. What we changed this to was y equals 4 plus negative 2 sine 3 times x minus pi over 3. So essentially this negative here, actually I'll wait to another video to explain. If you still have some confusions on like the actual translations and that's the way that you're using to graph, let me know and I can go over it specifically with you. But for now, I would just say the best way, just make sure that you're plugging in whatever x values you get from process part 2. Just plug back in and find your y values and make sure it's correct, okay? All right, let me save this and then I will pause and see if there's any questions.